This video is going to show how to make a parametric shelf in SolidWorks using top-down design and in-context references to make this. There's no complicated formulas or equations. It's basically just draw the parts and relate the parts to each other. Pretty simple. So I'll show you how I do this. I have an assembly template that has some additional planes that I like to have in here, and I have a 3D sketch that I use. I don't always use it, but it's in my template in case I need it. In this case, I will use it. I'm going to use it to define the overall size of this shelf. So I'll start by drawing a side. Let's do a rectangle and relate it to this 3D sketch. So it's fully defined by this 3D sketch. I change the size of the 3D sketch, that changes. And then I'm going to extrude that. My material thickness is typically 0.76, so I do that. Now I need to mirror it to the other side, so I'm going to use the mirror command. In SolidWorks, you can either make a copy of the part in a symmetrical location on the other side of the plane, or you can actually do a mirror image. I want to actually do a mirror image in this case, but you can do either one. Okay, so now I have my two sides. Now let me see, I'll create a base by drawing on this face, and I'll make it 3/4 thick, 3.76 thick. I'm going to make it 4 inches high. I'm going to extrude it up to the face of this part. So I just double click over here and it goes to up to surface, so it's automatically going to stay the correct size. I'm not figuring out, okay, well that's 48 inches minus inch and a half, actually minus 0.76 times 2. I'm just double clicking here and it'll keep it the right size. Okay, so now I have that. Let's say I'm just kind of making this up as we go. I'm going to draw a middle partition, I guess. So I'm going to do a construction line to keep that in the middle. There's a midpoint there, and then I'm using that to create this rectangle. And make this collinear. So now that will say the correct size as well, and then I will extrude this over to the other side. So it's really easy. Now I'm going to, so this is actually parametric already, so I could change the size, of course, by just changing this. Say I wanted 36, just update, all the parts change sizes. Say I wanted this to be 39, update, everything changes. Okay, so let's say I want to make a dado in here. I want to make this part dado into that part. So I'm going to edit this part, just do a little rectangle. Now I want this slot to be the same all the way around, so I make these little construction lines, and I'll go ahead and mirror them. Okay, and then I'll say I want it, 2.5 back. Say I want 4 inches here, 1/8 inch here. Merge result. Okay, so now I have my tabs, and now I need to make the slots. So I'm going to edit this part. Make an extrude cut. Just make a little rectangle. And I know I'm going to mirror it, so I might as well do it now. I can do it before or after I dimension it. Doesn't really matter. They're going to be related. So I'm going to make this a 1/2 inch. Give myself a 1/2 inch clearance for the cutters this direction. I usually go 0.005 on each side as far as my tolerances go. So there we have it. Okay, now I have my slots, and you'll notice that the other side also has the slots. It maintains the relationship with this. The mirror is going to always match. So, and then let's say I want to change this to a 1-inch thick base. All I have to do is double click, change it to 1 inch, update. You have your dados the correct size still. A lot of times the material will come in and it'll be a little different than we thought, so we have to change it. We have to go out and actually carefully measure it and make sure that it's going to fit our dados. And if it's not, we just come in and double click and change the thickness of the material to make sure it's going to work. So let me show you one more thing. SolidWorks has some automation as far as adding features that's kind of nice. I'll show you one real quick. I'll just randomly put a shelf on here. Okay, I'm going to go up to this surface, but let's say I want to back a 1/2 inch from that surface. You go offset from surface, 1/2 inch, and there you go. What I wanted to show you is, like, if you wanted to use knockdown fittings, for example, you just edit this part, and I have this library feature that you can just drag in and drop. So let's say I want 3 of these. Drag it and drop it. It tells you what edges are needed and what reference points are needed automatically, and you can see it automatically spaces them out for you. And you can double click on it, change it to 2 inches maybe. So it's real easy to drag and drop these features, and then to make it the hole in this part that it needs, you just edit this part. It's easier if you go to wireframe for this, and then extrude, just grab this edge, this edge, this edge. Okay, so now you can see we have the holes, and we have the fasteners and the holes, and they're related. So now if we were to change the location of this or the thickness of this, everything would update. So let's say we want it 18 inches high. It's real easy to change that. So that's pretty much it. Let me just show you how it changes. You can change the width to 24. Update. Everything changes. So you have a parametric shelf now. So we have a lot of sub-assemblies like drawers and shelves and cabinets, base cabinets, drawer boxes, stacks of drawers, anything like that we have pre-drawn where we just drag and drop it in there and make a few adjustments, and we don't have to redraw that every time. But as you can see, it's really fast to draw. You can draw unique things really fast as well, and you don't have to put all the equations into it and make it parametric if you're only doing it one time. But you can make your dados related, because that's almost always useful and it's really fast. So that's basically it.